Other students to join immediately. Session going to start. Shall we start, ma'am? Shanti, ma'am?
Yes, ma'am.
Yes, ma'am.
Ma'am, am I audible?
Yes, ma'am.
Okay, fine. Good evening to one and all present here. On behalf of SRM Valeme Engineering College, Department of Information Technology, I welcome you all for this webinar on overview of computer networks. Here we have a great personality, Mr. Vimal, to deliver his talk on this topic. About our resource person, Mr. Vimal, he has completed his Bachelor of Engineering degree in Ramakrishnan College of Technology, Trichy in the year 2015 and started his career as an analyst in HCL Technologies, Chennai. And currently he is working as a technical support engineer in Zoho Corporation Managing, Japan, providing email support with the help of online and human translators for all the Japanese customers and partners all around Japan as a one-man operation stationed in the country. His few accomplishments are he has completed 2 high-profile internships in college and he has designed a mini project on automatic dim dip headlight and on air-operated mixer. He has attended workshop on the topic Advanced Technologies in Automobile Engines hosted by Indian Institute of Technology. He has received certificates of appreciation twice during employment with HCL Technologies for efforts towards integration of Avago technologies with the Broadcom company. He has received certificates of appreciation for efforts towards operational excellence by HCL Technologies. He has earned a promotion from a technical support engineer's position to a global account manager's position during employment with HCL Technologies within the shortest span of time. He has shown keen interest and effectively learned manage engines products such as Service Desk Plus on premise and on demand in the shortest duration possible in order to be deployed to promote and support the applications in Japan. He is also familiar with IT related applications like Okta, Workday, Cisco ACS, Semantic PKI Manager, ServiceNow, etc. He is significantly good at handling administrative roles of Okta, G Suite, Box, Semantic PKI Client, AT&T, Verizon, and Singtel accounts. He has good knowledge on Active Directory and management of Windows Server environments. He has appreciable knowledge on Linux environments and other simple open source applications, and he is well versed in installation, configuration, and management of Java applications such as Manage Engines, Service Desk Plus, and AD Audit Plus. He is good in Python scripting and Postgres SQL query. So today we have such a wonderful personality with us to deliver a talk on computer networks, especially for third year students. Over to you, sir.
Thank you for the introduction, ma'am. That was a wonderful one. Hello, everyone. I understand that you guys are from the third year IT department. It's an honor to have a discussion with you all, conduct a webinar session. So I hope you're all doing well. It's a good day to connect for a webinar session. So I'm going to be sharing my screen to give you a basic PPT presentation. This is going to be a pretty basic one because the topic itself is a basic one. I'm sure you guys are aware of most of the topics which we will be covering in the overview of computer networking. Since this is going to be a common topic which you guys should be mostly aware of, I expect this session to be some kind of an interactive one, even though it's supposed to be a webinar session. I think some interaction would be really good. So I'm going to be sharing my screen now. I hope you all can see my screen.
Yes, sir.
Thank you. So firstly, we're going to start off with overview on computer networks. So we all know what computer networks are. Basically, A network is a collection of IP devices that can connect in a network. They have a separate IP address to identify themselves in a network. So we're going to be discussing about networking, how computers form a network, types of computer networks, topology, and a few basic concepts which you guys should be aware of: OSI model and TCP/IP model. It's not possible to skip these two models, right? So we'll be discussing about these two, and we also have some future technologies based on availability of time. We'll be discussing a little bit about future technologies that we have in computer networks that will be coming up in the future, very near future. Yes. So starting off with sorry. Starting off with what a network is. Can someone tell me what a network is? It's right here, but I want a real-time example, some kind of a real-time example.
Devices connected.
Please start with your name. Can you hear me?
Yes, sir.
Hello.
Yes, sir.
Okay. Please start with your name and give me an example of a basic network. All right. I guess that's fine. Are you guys able to hear me? If you can hear me, that's fine, I think.
Yes, sir, you are audible.
Okay. Okay.
The participants, you please interact with the speaker.
I think that's fine. That's okay. So basically, what is a network? A network is a collection of networking devices. Now, what is a networking device? A networking device is any device that can communicate with other devices when connected in the network. So what qualifies any device as a networking device? It should possess an IP address, right? It should have an IP address to be able to identify itself in a network, identify itself uniquely in a network. So these devices do not speak our language. So they have a way to identify themselves. They have a name to give to each other. That name is called IP addresses, right? So any device that has an IP address and can communicate with other devices is called a networking device. So we connect all these networking devices together to form a closed chain, which is called a circuit. And when such a installment is prepared, that's called a network. So what happens when we group these networking devices together to form a network? We can enable communication between each of these networking devices. So some of these networking devices could be computers, mainframe computers, printers, routers, switches, hubs, peripheral devices. When I say peripheral devices, I mean mouses, keyboards, webcams, etc. And we also have many other networking devices such as firewalls, proxies, etc. So when these devices are connected together to form a network, and they get to be able to share data. So when two people are chatting with each other, they are in a network. They formed a network. That network is enabling them to be able to communicate with each other. Let's consider our example. I'm sharing a screen here. We're all talking together. We're all in the same network. What is the network we're in? It's internet, right? So internet itself is the biggest network in the world. So next, we discussed about network and computer network here. We also discussed some basic networking devices. So this is an example of a home network. So this is this may not be exactly a home network because we may not have so many computers, but let's just assume these computers or other networking devices like printers, mobile phones, etc. So basically, we have these end user devices, printers, um, mobile phones, laptops, and computers. And then these are all connected to a hub, right? These are connected to a hub, and then they are further connected into a router. So hubs are devices that can connect to the end user devices directly, and these hubs can be connected to a router. So router is a more complicated device when compared to a hub. And nowadays, most routers developed by Cisco and any other networking company, hardware development company, they all include hubs, switches, and routers, and even modems within a router. So today's routers are like, robots. They can do a lot of tasks. So nowadays, we don't use hubs at homes, right? We directly connect all of our devices to the router because it performs the job of a hub, switch, and even a modem. So internet has become much easier now. So you just get a router at home, you connect to the router connects directly to the internet. There's no modem after a router. Earlier days, we used to have a modem after a router. So we used to have a modem, router, and then our devices, right? So that's how it used to be. So these hubs can also be replaced by wireless routers. So we used to have access points earlier, but now we have wireless access points within routers. So this whole diagram is the oldest one, and the latest one is just some devices, router, and internet, right? So this router can also handle wireless communication. So what are the advantages of computer networks? Computer networks allow sharing data. So right now we are sharing data, right? So computer networks allow people to connect with each other, communicate, and then share data with each other. So it's not just about the intellectual data, it's about physical files, right? When we have a file server in a network, I'll be able to share that file with other people, right? We have shared folders and shared data and stuff like that. So computer networks allow sharing data. They also facilitate collaboration and communication, like chatting and social media and stuff. They connect a lot of people together and they enable communication between them. So we all know that communication has become very easy, right? Nowadays, if you find anything wrong with our society or our police department, we just make a tweet tagging them. So it's become so easy to communicate, right? So that's a great feature of computer networks. We also get to share hardware. We get to share hardware devices. For example, let's say that we have a network printer at home. So it's not that only I can use that printer. Anyone using the same network, anyone who is a member of that network will be able to connect to that printer and use that hardware device. Printer itself is a hardware device. So they'd be able to use that printer. So we also have wireless printers nowadays, so it's become more convenient. So they're all in the network, and these computer networks allow sharing hardware such as printers. And they also allow sharing software, right? So nowadays we have all these Outlook programs and PowerPoint installed on the PC, right? So when we have these software installed on the PC, it's only that you can use that software, not others. But then now we have everything online, right? Just like we have Google Docs, Microsoft Word online, and every other technology company has online installments of all these software. So the basis of this kind of achievability is computer networks. So basically these Google Docs or Google PowerPoint or whichever software you have online, they're all installed on some computer on the internet around the globe. So when we try to access them, we access them through the cloud, but then we're all in the same networking, and networking is what is enabling us to be able to communicate and share that same software which is installed on one particular data center somewhere around the world, right? And then we also have disadvantages. For anything that has advantages, we also have disadvantages. So just because of these networking and computer networks, we have these virus and malware that's going around the globe, right? all of a sudden some kind of virus attacks of huge companies, computers and stuff like that. So we also have our own firewalls and many malware detection programs and stuff. So we have disadvantages with anything that has advantage. So that's the first disadvantage we have. We also have vulnerabilities. So with the improvement of technology, we also have lots of bugs that come with it. Any kind of software, when we keep improving, we also give them any new feature that is introduced in a software will give way for new bugs to be produced. Bugs in the sense vulnerability. So we have a lot of global vulnerabilities affecting a lot of products at all times. Companies producing those applications acknowledge those vulnerabilities, struggle hard to avoid them in their updated versions and stuff like that. So networking has also enabled remote connectivity, right? So someone can take access to someone else's computer over the network. So remote accessibility is also another way to induce vulnerability into data centers, thus causing harm to software installed on that data center and stuff like that. Obviously, computer networks are quite expensive. In order to enable communication, we need to set up a computer network, and we need someone to take care of those computer networks in order to ensure that they don't break. So it's a pretty expensive procedure. We also have a lot of hardware devices to buy in order to set up a successful computer network. What are types of computer networks? So all the stuff should be pretty easy and well known to you guys. So basically, computer networks are classified in a lot of different ways, right? At the first level, we have classification based on security. So based on security, we have private network and public network, right? So we know an example of private network, very easy example, which is home network, right? So home network is a private network. We have a password to our Wi-Fi. Only the members of our houses can connect to that Wi-Fi network by inputting the password. No one else can. So this is a private network, pretty secure one, but not very secure, right? But pretty secure one. But what is a public network? A public network is those networks in cafes and in a lot of public places where we don't have to enter any password. You just go into that range, you get a notification on your iPhone that this Wi-Fi exists. You just connect to it. So those are public networks who don't provide any level of security, but private networks obviously provide security in the form of passwords or OTPs. Most of the public Wi-Fi's nowadays do provide private network by providing OTP verification, but it's not as secure as password verification, right? So when you connect to the Wi-Fi of railway stations and stuff like that, once you access the browser, you have to enter your phone number, get an OTP, verify yourself with your OTP, and then you get to proceed. So most public networks are becoming private networks, at least to some extent, as much as possible, due to the reason of data breach and security vulnerability. So that's the basic difference between private and public networks. So next we have the classification based on geography, right? How networks can be typed based on how big they expand geographically, how big they expand, right? So the first one is personal area network. So personal area network is exactly my desk, for example, right? So in my desk, I have a computer. I have another computer which I use as a server. I have a mobile phone. I have a few other networking devices, right? So this small area, which is useful only to me, right? I have a few devices which are connected only for the purpose of me. That's called personal area network, right? So it spans to a very small space just for me. It supports just me, right? Next one is LAN, local area network. We all should have heard of this word. We use LAN for everything, for a lot of things, right? Sometimes we even call CAN as WAN. CAN stands for campus area network, right? So local area network is like a home network, which spans to a very small area, but it also provides support to a few other users within the small network. So a home network or even a office network, small office network can be LAN. So the next one we have is WLAN. The name is pretty obvious, wireless local area network. So any local area network that supports wireless connectivity can be called as WLAN. And CAN stands for campus area network. So a small campus spanning to a few floors of workspace can be called a campus. And that network, a network which covers this entire campus of these few floors, can be called as a CAN, right? So similarly, we have MAN, metropolitan area network. A metropolitan city has a huge connectivity, right? So all those public railway stations and stuff like that. So the entire network which covers a metropolitan city is called a MAN, right? Metropolitan area network. We have WAN, wide area network, which spans all the way through the globe, right? So how does the internet work? The internet works because every country is connected between each other by optical fiber cables, which are stuck under the ocean's bed, right? So we lay all these optical fiber cables under the oceans, connecting almost all countries now. I guess about 180 countries have these connections. They have internet. Those countries which don't have this don't have internet, right? So those are very rare countries and stuff. So all these connections that go through the ocean bed to connect two different continents and countries to be able to access internet, to become connected within a network, is called a WAN, wide area network. So we also have SAN, which stands for storage area network. SAN can also represent a few other types of computer networks, but we can go with SAN, which stands for storage area network. So we also have specific networks which are dedicated to include storage devices, right? Some kind of file transfer servers or hard disks. These devices are like physical hard disks, can be connected to a specific network, and they can be called SAN. The reason is because we might have to keep data secure, right? So we put all these storage devices into a particular network called SAN, so that we can easily manage that particular network. So the primary purpose of segregating these is to ensure that we get to manage these networks better. So when I have all these storage devices within one particular small network, I can increase the security for that network easier, right? So if rather than putting storage devices throughout my entire campus randomly, I won't be able to suddenly make changes to these storage devices. But if they are in a separate network, obviously I will be able to. Next, we have EPN, which stands for Enterprise Private Network. So before going to EPN, we should first go through VPN. So we all know VPN, Virtual Private Network. So literally, this is the word virtual tells you. So you're right here in India, but then you connect to a different country's VPN using a different country's IP address. And literally, it means that you're in a different country, right? So I'm right now in Japan, but there are a few official websites, government websites, which I won't be able to access from here because India does not host them, right? It's unnecessary. Some websites are not hosted on the internet. They're hosted within just India. So I have to connect to some kind of VPN service that provides me an Indian IP address. What happens here is that it literally means that even though I'm physically here in Japan, it means that I am one of you guys who are sitting in India connected to the internet. So it fools those websites and we'll be able to access them. So this is just one example, which is much easier to understand what a VPN is, but then we have a lot of really good applications of VPN. So just like we have VPN, we can go into EPN, Enterprise Private Network. Like how VPN provides support to users can connect to VPN, enterprises can connect to EPN, right? So a company can have multiple branches spanning to different countries, right? A company can have a branch in one country and another branch in other country. So these two companies have to collaborate with each other, maybe connect in a remote session, just like we're doing now, or they have to transfer data, very secure data. So they cannot just depend on internet. They cannot just use internet to, share important data. It could be easily compromised. So they need a separate network, virtually separate network. So that's called an EPN. So these two enterprises have a separate network and they form an EPN, just like VPN. So we also have classifications based on roles played by these network computers. So in a computer network, each networking device has a role to play, right? So a computer sends data, and computer gives us a lot of applications. A router in a network routes data traffic within that network. A hub in the network also does the same. It makes frames and manages network traffic and stuff like that. So each networking device in a network has its own roles. So considering the role of each networking device or networking computers, we can also classify computer networks into peer-to-peer network and client-server network. For example, in a peer-to-peer network, each computer acts as a server and a client, right? So let's say that we have 5 computers networked among each other, and all of these computers can have their own files, or they can host their own files, and they can also serve those files, right? So computer A can request file from B, and B can request file from A. So both of them act as clients and servers, right? So what is a client? A client is some computer that requests a service from another computer. The computer that provides that service is called the server, right? So if the computers in a network perform the role of both a client and a server, we can call it as a peer-to-peer network. So for example, what happens here is, let's say we all use BitTorrent and NewTorrent clients, right? So what these do is, when you try to download a movie from a website, the BitTorrent keeps track of all those users who recently downloaded the same file or same movie from that same website, right? So when you try to download it, the BitTorrent client does not just connect only to that particular website. For example, any torrent site, it doesn't connect directly to that torrent site to download that download that movie, because when you do that, it's going to take a lot of time for that server to share that entire movie back to you in order to serve that entire movie back to you. So what that client does is, BitTorrent client or whichever torrent client, what it does is, it just gets the torrent file from the website, just a minor file from the website, and then it keeps track of all those people who downloaded, right? So they would be seeding. When you enable seeding in BitTorrent clients, it means that your machine is gonna serve as a server to send the downloaded file to any requesting peers, right? So all these members of a peer-to-peer network are called peers. That's why we call them as the network itself as peer-to-peer network. So when you enable seeding in your BitTorrent client, what happens is, it's going to constantly keep looking for peers who are trying to download the same movie from that torrent site, right? So unknowingly, even though you're not using your computer, you just have it powered on, it is seeding the downloaded file over to someone who is downloading it. For example, if I download a movie now, and if yesterday about 10 people had downloaded it, I get bits and pieces of that movie from each of them, each of those 10 people who are seeding that movie. So what happens here is that I would be able to download that movie much easier and more quickly, right? But this peer-to-peer network, since it involves a lot of devices serving as servers, they perform as servers, they also serve as malware spreaders, right? Because these are, you need to consider that these are not actually secure servers. These are just someone else's computer working as servers, right? So they might have a lot of malware and viruses on the computers. So those get shared to my computer as well. So peer-to-peer network, even though that's a really great technology, which actually reduces the time consumed to perform communication or data sharing, it's very vulnerable. So it's not very much used nowadays. It's rarely used nowadays, right? Except for these BitTorrent and NewTorrent clients, etc. But we often use client-server network nowadays. So literally, client-server network itself means there's a dedicated server, some kind of a data center. The only purpose that it does is it serves network traffic. It serves data. So clients request data, and that server gives you data back. So there's no the other way around. The server never requests data from the client, right? Client has nothing to provide. For example, we all went to teams.microsoft.com. So we are the client requesting for the teams.microsoft.com service, and the Microsoft server somewhere in the US or some other country, it serves back that application to you, right? So we mostly have client server networks nowadays, just for the sake of security. We do have a lot of many advantages of the client server network, but the primary reason is to ensure security and easy management, right? So when there's a server at one particular area, if teams.microsoft.com goes down, they can easily go into that data center and fix it, right? So they know exactly where that application is. But then if we have teams.microsoft.com scattered over like in a peer-to-peer network, they won't know which computer to go fix what issue, right? So we have many other advantages and disadvantages. Next, we have topology of computer networks. So basically, this should be pretty easy for you all. Let's start with bus topology, right? So in bus topology, we have a backbone, a main line through which data is sent or received, and we also have branches connecting to various computers or various peripheral devices or other networking devices which connect to the end user, right? So end users devices are always taken out in a branched connectivity from the main line, which is also called backbone. So there are a lot of advantages, right? So this is a very simple network. So if there is a network like this, maybe at your house, I'm sure you would be able to fix any issues in it, right? So if there is some kind of network failure, and if that network failure is happening only for you, you know where the problem is. The problem is right there in that particular line, in that particular branch that connects your computer to the backbone. But on the other case, if there's a network failure to all the computers that are in the house, you know that the entire backbone is gone, right? So the network is really simple. Anyone can understand it. We can easily troubleshoot it, and it consumes very less amount of cables, so we don't have to put a lot of money on cables, and it's a pretty simple network. But it also comes with a lot of disadvantages, right? So if the backbone goes wrong, the entire network is down. No one is able to access the network, right? So that's a huge drawback. So it also has a few drawbacks such as bandwidth problems, right? So since all the data traffic go through commonly through the backbone, we also have backbone prone to a lot of bandwidth issues such that it could fail, right? So those are some kind of basic advantages and disadvantages of bus topology. So next we have the ring topology, right? So ring topology, it's pretty easy. We connect all computers through cables which go through each and every one, right? So it's pretty easy. The number of input output devices that you need, number of input output ports, physical ports that you need here is just 2, because each computer is connected to 2 cables on either sides of their devices. So it's simply like a simple topology. But this also has a lot of problems, right? So when data can go through this kind of a network, if computer A wants to send some data to computer C, it has to go through B, right? So it has to go through B. So that's a security vulnerability, right? So we also don't have a backbone here. So all the traffic has to go through only the available cables, thus resulting in bandwidth issues, right? And we also have, if one computer goes down, the entire network goes down. So earlier we just had the dependency on the backbone in bus topology, but in ring topology, we have the dependency on all computers. So if any computer goes down, the entire network goes down, right? Even if any cable goes down, the entire network is down. So this is more vulnerable, and this is not a very sought upon solution to prepare a network, right? So next we have star topology, in which we have a common device at the center. It could be a server, or it could be a computer which provides services, or which maybe just connects, which simply performs the task of connecting with all the computers around. So it could be a hub, right? A hub is a simple device which connects multiple devices in a network. So here the advantage, just like bus topology, is that every device in star topology just needs one input output physical port, right? Because they have just one cable going out from them. But the hub obviously has to have at least 4 or 5 ports depending on number of devices on that particular network, right? So this one is a very good topology when compared to ring and bus topology, because we have a central managing device called the hub at the middle, right? So we can manage the entire network just using that particular hub, right? So obviously, if the hub goes down, as a disadvantage, if the hub goes down, the entire network is down. But if one particular cable goes down, nothing happens. Just that particular device is down. The network is just good, really good, right? And we also have other advantages of the star topology, such as not all traffic go through all cables, right? It doesn't go through other machines. It just goes to that particular machine. So if you put a hub there, a hub is not an intelligent device when compared to router. We'll be discussing the difference between hub and routers when we go into OSI model. So when we have a maybe more intelligent device, better than hub, which is a router, we also can reduce the amount of bandwidth that goes through each and every computer and stuff like that. So we can actually improvise the topology, but it still has some disadvantages, such as the central device or the hub or the router going down, right? But this is definitely a better topology when compared to the earlier ones, which didn't have a central managing authority, ring topology and this topology. And then we have tree topology, in which this is more like a tree topology is more like a hybrid topology itself, right? So tree topology can also be called a hybrid topology because it combines two different topologies together. So if you want to guess what those two topologies are, the first one is the star topology. We have two different networks which are formed based on star topology. And then these two star topologies, these two central devices or central hubs are connected within a central backbone, which thus forms a bus topology, right? So it's not just restricted that we have to have a particular type of combinations to form a hybrid topology. It depends on completely the applications or the necessities of that particular networking environment, right? So we can combine ring topology and star topology, ring topology and bus topology, and stuff like that. So here we have a ring topology with bus topology, right? Sorry, star topology with bus topology, right? And then we have mesh topology, which is better than any other topology, but it also has its own disadvantages. As you can see, the mesh topology has dedicated lines connecting each and every other device on the network, right? So if I have 5 devices, I have exactly single cable connecting each other device. So every device is connected to every other device. So we also have a formula to calculate the number of cables that we need here. Let's say that n is 5, the total number of devices on the network is 5. So n into n minus 1 by 2 gives the number of total cables that you actually need in order to form the mesh topology. So the mesh topology is a really good one. It's robust because it has dedicated cables. So if A wants to send data to F, it can send it directly. It doesn't have to go through other computers. It doesn't even have to go through other cables, right? It has just one cable which connects directly from A to F or whichever 2 devices. It's literally like just 2 devices connected in a group of network, right? So this is really robust, and it's got better bandwidth because it doesn't go through all cables, and it's pretty fast. It doesn't lead to network collision. It doesn't have two-way communication because it just connects between 2 computers, not between 3 or 4 computers. So it's got just direct connections which lead to a better solution, right? But it's got its own disadvantages, such as it needs better maintenance, right? Because it's a pretty complicated topology when compared to the other ones, and it also is more expensive because of the involvement of a lot of cables, right? But then error detection is much easy. If something goes wrong, if some particular communication goes wrong, it simply easily points out to the particular device or the particular cable that's connected between two different devices, which can be easily identified and then fixed later, right? Next, we have basic concepts of computer networks. So the first one that we have here is Open Systems Interconnection Model, which is basically a representation or a theoretical framework of communication between two network devices over the internet, right? Let's just consider internet because these are two different devices which are connected between um, a WAN link, which are present in two different countries. Let's just consider that way. So this OSI model literally explains how any data packet transfers from one machine to another machine, right? So it literally helps us visualize how data transfers from one machine to another machine. So the next one that we have here is TCP/IP model, which is actually the one that we have in real-time environments. Internet works based on TCP/IP model, even though OSI model is more robust and more older. It's not the one that was used in real time for a long time, right? So OSI model was a standard. It was standardized by the International Organization for Standardization in the year 1983, right? So this was even, this was released in 1983, but it was standardized in 1984. So consider how explanatory this model should be in order for it to be standardized within 1 year since it was released, right? So this was a very common model which was used for network communication and troubleshooting network communication around the 1980s until the internet era evolved. So uh, it was actually not possible. Like even though OSI model is what helped develop a network called internet, it was not possible to publish the internet throughout the globe just by using OSI model. So that's when TCP/IP had to be brought into picture, right? So these are some basic introduction about OSI models and TCP/IP models. So this is basically the OSI model. It has 7 layers, starting with the application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. So this OSI model, even though it is not available as a real-time usage right now, it helps networking engineers really well. It helps me in my work here. Sometimes I handle data center implementation here in Japan. We have 2 data centers, one in Tokyo and other one in Osaka. And this really helps me, even in a data center, to really troubleshoot issues in that data center. So basically on the application layer, we have devices or programs such as web programs, such as web browsers and email clients that actually generate data that need to be shared over the network, right? So we have web browsers such as Google Chrome and Mozilla Firefox and even Thunderbird. We have email clients like Thunderbird and Outlook, which generate data. When you send an email, that email gets converted into data packets and other bits and signals in order to be transferred over to the other device on the other end, right? So on the application layer, we have the data, which is broken down, and then it is available as characters and numbers, right? Which is then converted into segments, right? It is converted into segmentation, and further it is taken over to the presentation layer, where the data is actually presented in a way by processing it, right? It changes them into segments and provides them over to the session layer, which actually enables creation of a session. It creates a session to send all these data packets over to the transport layer. So the session that is created by the session layer is used by the transport layer for the purpose of transmitting these data packets over to the network layer. Where network layer is where these packets are named by including the IP addresses, right? And then these IP addresses enable these sending and receiving devices to be able to identify the sender and the receiver, and thus the data gets sent to the data link layer, where MAC addresses are used as headers and tails in order to identify them as frames, and they're further converted into signals to be able to transmit them using the physical media such as Wi-Fi signals or radio signals or electrical signals. So this is a generic basic overview of what happens with the OSI model. So this basically has a lot of protocols that work at different layers of the OSI model. So examples of some protocols that work at the application layer or HTTPS, FTP, and SNMP, SMTP, etc. On the presentation layer, we have a few protocols, and similarly, we have a set of protocols for other layers as well. Notable protocols that we have to discuss about are the TCP and the UDP protocols, which work at the transport layer. And we also have some protocols such as OSPF, Open Shortest Path First, and we also have BGP and a few other protocols at the network layer, right? So moving on to the TCP IP suite, considering the time we have, we just have about 10 to 15 minutes. So let's just move on to the Internet Protocol suite. So the difference between OSI model and TCP IP model is that we've just compressed a few layers, right? So in the real-time Internet world, the first three sessions, first three layers are performed by the application layer itself. For example, when you access a website, the web browser itself performs the activities of the application layer, presentation layer, and the session layer. So even though it just receives the information from the user, it also converts the data into segments, creates a session, and that's when the transport layer takes up those packets and converts them into frames and transmits the data. So this exact model happens in the reverse order on the reception on the recipient's end, in order for the data to be processed and provided to the end user on the other end. So finally, we have the future technologies in computer networks. So obviously, we cannot talk about future technologies without artificial intelligence, right? So artificial intelligence and machine learning go hand on hand, and basically, artificial intelligence enables devices to be able to use some human intelligence to reduce human tasks, right? So, for example, we also have we should have heard of Elon Musk using SpaceX. He has landed rockets back using AI technology, right? So AI is really helping in a lot of ways. In fact, Tesla itself is a car, but it uses AI. So AI is going to be transforming the future of computer networks very much. And then we have 5G. So we all should have heard of 5G, which is already booming in India in important cities, right? So 5G enables better bandwidth and better frequency and better speed, and it also comes with Internet of Things, right? So 5G primarily enables Internet of Things. We already have a lot of hardware, mobile device marketers who roll out 5G devices such as Apple, Samsung, and Qualcomm, which is actually the owner of 5G, is rolling out and is already ruling the market with its 5G devices, right? And Internet of Things is another technology that will be booming. It simply makes every device a networking device, right? So far we've been using networking devices such as computers and mobile phones and network printers to be able to connect in a network, right? But now we're going to, with Internet of Things, we would be able to convert any device into a networking device so that it can be added into the network for easy management and data sharing and stuff like that, right? So next we have Wi-Fi 6 and Wi-Fi 7. Does anyone want to say anything? All right, next we have Wi-Fi 6 and Wi-Fi 7. So Wi-Fi 6, let's consider that the generic speed of Wi-Fi that we have right now is 3.5 Gbps. Wi-Fi 6 enables up to 9.6 Gbps. So that's a huge leap for mankind. So Wi-Fi 6 is just about to be common, and this enables bigger bandwidth, better frequencies, and more devices to be able to connect into its Wi-Fi network. So we already have a few companies developing Wi-Fi 6 enabled routers, which can support a lot more of devices, and it also enables easy management of all those connected devices. So that's a really huge leap, providing improvement in every aspect such as bandwidth, frequency, and even speed, right? And then we have Wi-Fi 7. This is not going to bring any kind of new technology in the field of Wi-Fi market, but then this is going to increase the speed and basic improvements to Wi-Fi 6, right? So Wi-Fi 7 is still in the basic starting stage because Wi-Fi 6 itself is about to be, is still yet to become very common, right? So we might be able to expect more features with Wi-Fi 7 in the future, but right now we just have improvements to Wi-Fi 6. We don't have any specific technology that come out with Wi-Fi 7. So next we have ambient backscatter, right? So this should be pretty bad that people would have heard about it. So this is pretty much like the AirTags of Apple devices, right? So Apple has released AirTags, which are just like coins, right? They look like coin devices, but they have a battery in them. So that battery is a coin battery, which can stand up to about a year or even 2 years, right? So we can add those AirTags into any devices, thus making them as communicatable devices, right? So if you lose your keys or something like that, you can use AirTags to identify the location of your keys, or maybe if you go into a very busy area and if you park your car somewhere, if you have an AirTag in your car, you can easily identify the location of that car and get back to it. So this is a really good technology. It is a start for ambient backscatter, but basically AirTags work based on batteries and they use Bluetooth technology, right? So ambient backscatter literally removes the usage of battery and also does not use Bluetooth. So this is going to be a better technology with better efficiency because ambient backscatter, what it does is it does not require a battery to be able to generate its own radio signals, right? So radios, all the networking devices or all the devices that have a battery literally generate radio signals in order to be able to communicate with its other devices. But what ambient backscatter is going to do is it doesn't have a battery, so it doesn't have to, it cannot generate new radio signals. But we all know that there is a lot of radio signals around us, right? So there are lots of TV towers, lots of devices that emit Wi-Fi routers around us that obviously emit radio signals all the time. So ambient backscatters uses the available, keeps detecting available radio signals around the location, and when it wants to convey something to its other devices, it reflects those existing radio signals. So that's how it's easy to communicate, and it's going to change the way AirTags work today, right? And finally, we have IPv6. We've been hearing about this technology for a pretty long time, but it's already been implemented. Pretty much, it's already been implemented. So we already use the protocols such as ping to test connectivity. So earlier we used to have, when we used to try to ping some device, it's going to list the IP address in the form of IPv4, but we nowadays see in Windows 10 that by default, ipconfig reflects IPv6 addresses, right? So if you want a IPv4 address to be reflected by the ping command, you need to include the -4 parameter, right? So IPv6 is already becoming normal, right? So IPv6 is a really great technology because IPv4, which we've been using all this while, can support only 4 billion devices, right? So nowadays, each of us have a lot of networking device within our personal area network, right? Just like I told you, I have a laptop, I have a server. I'm sorry? Does anyone want to say something? All right, I'll
Yes.
carry.
Yeah, please carry on, sir. Yes, sir.
Okay, thank you. So within the space of a personal area network, we have a lot of devices. Just like I told you, I have a laptop, I have a server, I have a computer. I have a mobile device and many other networking devices. So each of us have at least about 5 to 6 networking devices already. So this number is going to exceed 4 billion. And because of this, we cannot have more users and more collaboration on the internet. So to avoid this, networking engineers have been working on a better methodology for a really long time, and that's when they came up with IPv6, which involves combinations of hexadecimal characters, right? So currently in IPv4, we only have numbers. So the number of permutations and computations and combinations that you can develop with numbers is minimal. That are 4 sets of octets. So we have only so much, 192.168.1.1. You can only get up to a few number of combinations. But in the case of IPv6, we have a huge number, which includes alphabets too, right? Which includes the characters of alphabet. So it's much easier to be able to get a really huge number of unique identifying IP addresses, which mankind may never run over, right? So this number will be very much enough for a very long future. So IPv6 has been a great technology, but it's been hard to adopt to IPv6, even though IPv6 has been released and it's been pushed by companies like Microsoft, just like in Windows 10. We all prefer IPv4 for a number of reasons, right? Because it's easy to remember. I can easily ask my coworker sitting next to me for the IP address of some server, and he can easily tell me by his from the top of his mind, right? Because it's just a 4 set of octets. But in the case of IPv6, it's hard. So it's not easy for us to use IPv6, right? So it's been hard to switch over from IPv4 to IPv6, but networking engineers are doing their best. And we also have networking hardware companies, which also try to enforce IPv6 in order to be able to move to IPv6 for a better future of networking in computers, right? So finally we have the summary. We discussed networks, computer networks, types of computers, and computer networks. We also discussed topology of computer networks, basic concepts such as OSI model and TCP/IP model, and we also discussed some of many future technologies that are going on with computer network, right? So that's all I have for this session. I think it's time, and I'm glad I didn't take up much of your time. So if you have any questions, you can let me know. Does anyone have any questions?
Students, do you have any queries?
All right. I'm glad I completed this session, and by the end of the session, I didn't take much of your time. And if you have any questions, Shanba ma'am has my
Yes.
email address, and she also has my other contact information. So anyone can connect with me regarding any kind of, I'm sure all these that we discussed today are something that you would have learned in your subjects already. But if you need any help with real-time environments, or I do have, just like ma'am read out in the beginning, I do have a lot of experience with data centers and other applications. So if any of you have any queries or doubts, you can feel free to reach out to me. I'd be happy to do the best I can. Thank you for this great opportunity.
Thank you, sir. Yes, sir.
Thank you, sir.
Yes, sir. Ma'am? HOD ma'am? Yes, ma'am?
Yes, ma'am.
Yes, ma'am. Yes, ma'am. Yes, ma'am.
From my
Yes.
side, there is no questions.
Okay. Okay. Thank you.
The session explained by Vimal is very nicely explained.
Yes. ma'am.
Thank you.
Thanks for coming and giving the lecture, sir.
Thank you.
Yes, ma'am.
Thank you, sir.
Thank you. Thanks,
Thank you.
everyone.
Students, 1 minute. Feedback link for the today's session posted in the chat box. It's mandatory to get the certificates. Okay. Kindly fill the fill the form. It's very important. Okay. Okay.
Okay,
Sir.
ma'am.
Yes, sir. Ma'am, shall I deliver the vote of thanks for this
Yes,
event, ma'am?
we can proceed, ma'am.
Thank you, ma'am. Yes, a very good evening to one and all present here. It's my great pleasure for me to deliver the vote of thanks for this event. I would like to thank our honorable resource person, Vimal, Zoho Corporation Management in Japan, for sharing his knowledge on computer networks. Thank you, sir. And he explained about each network, personal area network, local area network, wide area network, metropolitan area network with real-time example. Was very well, sir. And you explained about the drawbacks of each and every topology. That's very nice, sir. And you explained about the future technologies in computer networks like ambient backscatter, Wi-Fi 6, Wi-Fi 7, that and all very nice. Overall, the real-time example was very nice, sir. Thank you, sir. I would like to thank God Almighty and our management, principal sir, vice principal sir, and our beloved HOD ma'am for constantly encouraging us to conduct such a kind of event. I would like to thank my fellow colleague, Ms. Shanti ma'am, for conducting this event in an effective manner. And I also thank our supporting student committee from our Department of IT. They are also involved many work in this program. I thank all the student participants from third year and also some of the outsider participants also. Thank you for making this event as a grand success. Thank you, sir. Thank you, Vimal, sir. Thank you, sir.
Thank you again. Thank you,
Yes,
everyone.
sir. Nice
Thank you,
session, sir. Thank you, sir. Sir.
Thanks a lot.
Students, don't forget, kindly fill the feedback form, which I posted in the chat box.
Hello, ma'am.
Yes, sir. Yes, sir.
Ma'am, the chat box is not visible, ma'am.
Okay, sir. It's visible to our students, sir. Kindly, I will specify my number, sir. If you want that certificates, kindly send it to my number, sir. 99. Will you please note down my number, sir? 99. Yes, sir. I'll tell my number, sir. You kindly send in message to that number. I will give you the feedback link, sir. Yes, sir. And
I'm sorry,
definitely,
ma'am.
yeah, yes, sir.
I'm sorry, ma'am. I didn't ask that question. I'm sorry. You seem to be addressing
Ma'am,
me.
I'm
but-
student, ma'am.
Yeah, I know Pandi Selvam,
Okay.
sir. Yes, sir.
Okay.
It's true that Pandi Selvam. Yeah, you are student. From where, Pandi Selvam? Yes.
SRM, ma'am. Triple E.
Okay, sir. Okay, thank you, Pandi Selvam. 99. Kindly note my number.
Yes, ma'am.
Yes, just a minute.